Thank you all so much for joining me today. I'm really excited to get to give this presentation. It's been a bit of a sort of a passion side project for me over the course of the last almost year that I've been getting deeper and deeper into this technology, and I'll explain a little bit more about why in a minute. My name is Ray Deck. I'm CTO of a company called Elma 55 based out of Cambridge, Massachusetts. And I'm also CTO of a company that currently is called Privilege Incorporated that is based out of the Seacoast. And I have, just in the course of the last year, been trying to get more familiar with where the new hotness is in JavaScript, and really came across React, which is one of several options for being able to much more quickly and scalably build web-based applications, and some pretty cool stuff. But the truth is, I'm not actually much of a JavaScript developer. I'm not really a web person. What I really am is a native developer, going back to the building in mobile, going back to the J2ME days and CLDC days, for those who remember that with BlackBerry, back in like 2004. And I kind of wanted to be extending that to be able to make make JavaScript the boss of all the things without having to use hybrid apps. I was starting to go down the road of building my own platform for doing this when I discovered that React actually has a kid brother. And React Native, which I've now been involved in for about 14 months, allows us to control native technologies using JavaScript. In fact, there are a few options for doing that. Like there's Xamarin, which is out there, which was the subject of a 9 o'clock talk. Unity actually is cross-platform as well, and also allows control via JavaScript, although Mono is more popular. That was the 10 o'clock talk. Today I'll be talking, right now I'm talking about controlling using React Native and applying it specifically to augmented reality. And I'm pretty sure that at 12, the folks at Telerik are going to be talking about NativeScript. So you're going to get the full panoply of JavaScript to control the things. But for me, the big advantages of getting to work with React Native as opposed to just being a straight-up native developer really boil down to three major considerations. The first is, as a matter of developer experience, React Native offers this instant, very rapid reloading, which allows a high rate of iteration as I discover what's going on with an application. I'll be showing some of that in just a few minutes. Being able to treat the core code, the orchestration code of my app as an asset. And this is actually a really key consideration here. Has anybody here shipped to the App Store or to Google Play before? A couple people? Okay. So there's usually this process that takes a matter of days to get approved, particularly on the Apple side. It takes more like hours on the Android side. And the key is that anything that's in binary needs to be resubmitted through the App Store, but that doesn't actually apply to assets. You can have new images, you can have new text, etc. That's all expected to be updated over the air, and that doesn't require resubmission to the App Store. One of the very cool things about having your app be controlled, at least at a high level, by JavaScript is that JavaScript is treated as text, which means it's an asset. And that means we can be deploying new text, which is the JavaScript, to create substantial new variations in the way our code works as an over-the-air update without requiring a new binary update that then requires review through the App Store. And finally, the last big advantage I would say of React Native as React Native is it allows you to use React to actually compose your UIs. We'll be talking about that in just a minute. Now, under the covers, this is not the way JavaScript works in a browser. This is actually headless JavaScript that probably has more in common with using Node than it does using JavaScript in the DOM. It is orchestrating the way the rest of the native components are going to work. And this is a simplified diagram of how a React Native application works under the covers, where you have a JavaScript core instance. This is headless JavaScript that is in its own runtime, on its own thread. It is communicating with these other native components, like your UI, or your network subsystem, or storage, etc., over this bridge that's running on a second thread. And neither of these threads are the same as the UI thread. which means that the UI thread gets freed up for doing all of that display that we're used to on the front end and being able to respond to user interactivity without getting held up by business logic, processing, etc. And as a result, you get something that's pretty buttery smooth. Certainly has its limitations. We could talk about those if anyone's interested in that. But as a way of having an app that is controlled by JavaScript, where it's like the brain of the app, but the body of the app is still in these binaries that are being controlled through the bridge, which is kind of acting like the spinal cord, right? So you have the brain's replaceable, you have the spinal cord and the body, that's all being distributed as binaries. That's the part that's going through the App Store, which allows you to have a much more powerful and, in fact, much more mutable application that you can then bring to your customers. Now, I got interested in this, but like I say, I didn't come at this from being a web developer. I came at this from being a native developer. And really what I want to do is make use of this technology that allows iOS apps to be, I find, much easier to work with, which is, say, develop in Swift as opposed to developing in Objective-C. There may be Objective-C fans in the room. That's okay. There are dozens of you. What I have found is that Swift is much easier to work with. And Swift looks a lot more like, well, Kotlin, if anyone's worked with that. It also looks a lot more like Java and much more like what we now consider to be high-level object-oriented object-oriented languages and functional languages. The trick is that React Native doesn't think in Swift. React Native, in terms of the components that the folks at Facebook, who are largely the maintainers of React Native, have come up with behind the scenes, is actually written on the iOS side in Objective-C. And so one of my first big contributions to the React Native ecosystem was actually creating components that would allow one to develop in Swift for React Native. And I've done this in terms of a number of components that are all released on NPM. And I actually had the privilege of getting to speak at the React Native conference called Chain React this past July, talking about bringing machine learning technologies into React Native as well. But I've always been really excited about trying to use this in a way that's not just traditional UI, right? Not just buttons. How can we express through a DOM in this very reactive way augmented reality? And I'm not the first one to the party on this. There are a few other packages out there that are thinking about these things. There's a company called Expo that has an API for React Native that's built on top of three.js, which is kind of interesting. That's open source. There's a company called Viro, which has made a React Native subsystem that's also pretty useful. It is not open source. They're currently distributing it for free, but it is closed source. It's their IP. And third, and this is the one I really latched onto, is this thing called react-native-arkit, which was an Objective-C written extension library for React Native that would allow you to use ARKit and augmented reality with React Native. And my first effort at this was actually taking the Swift knowledge I had and saying, let's port React Native ARKit into Swift and learn more about how to make React Native and Swift work together. I got deeper into this and found myself leaving the way React Native ARKit was working with things behind, and actually getting much more into trying to make AR more Reacty, being able to think about a deeper node tree. And I'll talk about that in just a couple minutes when we get to the demo part. And as a result, I stopped calling it React Native ARKit Swift, which is sort of part of my port. And especially after chatting with the couple of Swiss folks who make React Native ARKit, I renamed it, and now I call it React Reality. And it's this system that I'm going to be talking about more today. React Reality is available on GitHub. It is under MIT license. You can play with it to the extent that you like, and I would definitely welcome contributions. And this is sort of a coming out party for it, where I'll be talking about what it is and how to use it, and I'm looking to really be getting feedback on it. And it is now also available on NPM for download, just using npmi or yarn-add. And that is true as of about 24 hours ago. So I might instead call this talk not augmented reality with JavaScript, but augmented reality specifically with this library built called React Reality, trying to make it much easier. Where my mission is to make it easy to create simple AR experiences. I'm not trying to recreate super complicated video games. Unity is really good for that. I'm not trying to create a physics engine. What I want to do is be able to take that which is best about React in terms of expressing declaratively this is a scenario I want to be in, and have it be interactive, and make it that someone can, in mobile context, be able to bring AR into that so that we can be just creating richer experiences for our users. But to understand why that might be hard, we should look a little bit about what augmented reality is, which is the combination of reality and data. Data is virtual. Reality is the context of the world around us. And that means in order for us to take advantage of that, there are two things that are needed. You need sensors to understand our context, right? Because if you don't have sensors, what's reality? And second, you're going to need some way of rendering in the context that those sensors have picked up. Now, when we talk about sensors and we talk about reality, we're talking about ourselves and the world around us. Really, we can think of it in terms of pose and position of the various objects in the world, starting with ourselves. And so, has anyone here heard the term 6 degrees of freedom? Okay. This is a big idea when you're talking about like VR and AR. The 6 degrees of freedom start with pose. And pose would be the direction that you might be looking. You can think of it in 3 degrees. The first, on one axis, would be like nodding your head, right? This is generally called x-axis rotation. The second would be shaking your head, as if there's a line straight through my top. That's y-axis rotation. And then being able to kind of waggle my head. That's the third axis. And those three things together we can understand as a result of having a gyroscope. Because a gyroscope takes advantage of the fact that we all live in an accelerating frame of reference down, which is the Earth's gravity. And so we can now understand our relative position to the Earth's gravity in terms of each of those three dimensions. That's the reason, for example, why Google Cardboard could work as long ago as like a few years ago when it came out, because it took advantage of changes in pose of the phone, because the phone has a gyroscope built into it. And we can turn that into absolute terms as well, because in addition to knowing which way is down, we can know which way is north, and that's what the compass gives us. And that's stuff we all get from the sensors for free. Now, we've had that for a few years. So what makes ARKit special is that it then brings two new sensors to the party in order to give us the additional 3 degrees of freedom. And those 3 degrees of freedom are being able to move forward and backward, move side to side, and move down and up. So motion along each of those 3 axes is the idea of changing position. And when you take the 3 of pose and the 3 of position, that's your 6 degrees of freedom. And in order for it to figure that out, it makes use of the camera and GPS to figure out your relative location. And the camera part is the one that's really a trick, because it's trying to figure out, based on relative fuzziness of what it sees in the camera and how things change over time, basically using the same tricks your brain uses to figure out where you might be, to understand its own position and changes in position over time. This is what the AR systems do that's different from the VR systems, is getting it from your context. And so there's in Apple, you have ARKit, which is all about leveraging those sensors to give you your relative pose and position, and by looking out into the world, the potential pose and position of other objects as well, context. And that's been out now since 2017, and more recently this year, Google came out with Android's answer to this, which is called AR Core. But it's worth remembering that both of these are solely about the sensors, right? It's just about that context. But in order for this to be useful, I talk about augmented reality being both the sensors and the rendering. And that's where Apple is leveraging this technology called SceneKit that's existed in the iPhone and in iOS since I think 2015, 2016, which was pretty mature, which they can then latch ARKit onto to create a combined experience that could work pretty well. As opposed to Android, which actually had no 3D rendering system. In fact, when AR Core first came out, you basically had to go write yourself some, Core GL in order to draw anything that'd be based on what you learned from AR Core. Unity stepped into that gap, right? Because Unity already had a rendering engine that was available that would work both in Android and in iOS. And so as soon as ARKit comes out, Unity hooks its rendering engine up to that, and was also, when AR Core came out, hooked its rendering engine up to that so you wouldn't be exposed to that. So actually for a long time, your best option for doing any AR work on Android was to be using Unity with AR Core, and that works pretty well. Very recently, Android came out with something called SceneForm, which is kind of their answer to SceneKit. In theory, this means you should be able to build apps with SceneForm and AR Core. In reality, SceneForm is still actually pretty immature, and is something I'm sort of watching to make sure, okay, when's it going to be mature enough that I can be taking advantage of it? Because the things I'm going to be showing you today, I've built on top of iOS because it's taking advantage of the existing maturity that we have in ARKit and SceneKit. And as I went into it, AR Core was easy to integrate with, but SceneForm, right, that last part, this lower one, was really what was lacking and was the reason why I didn't go down this road. So the two, if you're interested in doing Android AR work, I could recommend to you Unity, and also the folks at Viro made their own rendering engine specifically for Android to solve this. But my expectation is that probably React-Reality, the package I've worked on, will, by, say, first quarter of next year, have Android support as well, really as a result of SceneForm becoming more mature and more leverageable. Because my concern is trying to make something that's easy to work with. I'm concerned about developer experience. And that's the reason why, in addition to creating React-Reality, I created something called React-Reality CLI, which allows one to relatively easily spin up a project that takes advantage of React-Reality. You can also, of course, inject React-Reality into your existing React Native app. But this allows you to relatively quickly come up with, hey, how can I just get started? And it's that getting started app that we'll cut to now. And so what I'm showing right now is my phone. Hello, phone. Show me phone. All right, there we go. And I'm going to bring up an app that I deployed. And by the way, the GitHub repository for all the code you're going to see, I'm going to show after the demo. Now, one of the big advantages is that all this code that's being done that is expressed in like Swift and in Objective-C is, of course, over in my Xcode. But my Xcode is not currently running this in debug mode. This app is simply running by itself on my phone, but it is connected to my it's connected to my JavaScript code using a development server. And that's what allows the very rapid reload that you're about to see. So this is your basic Hello World app where it's able to say, oh, hey, it's northward direction. And it can do that because the app in JavaScript is importing React, importing some components, and then rendering. By the way, I don't know if this JSX syntax, is anybody here like not that familiar with JSX? I should be explaining what it is we're looking at here. We're okay with it? Okay. The syntax here is called JSX, which is sort of an HTML-ish format for being able to basically lay out code, and particularly lay out UI elements. So behind the scenes, it's getting transpiled into actually raw JavaScript. But from my developer experience point of view, I can say, well, what I want to do is have my app show what I'm calling a mono view, which is a monoscopic view into the augmented reality world, where it is previewing for me, the context of the world that it sees around me, and laying out inside of that view, the things in 3D, like the fact that this text is north. This is being defined based on the fact that the augmented reality session is aligned based on a compass. And so with a z-axis of 4 is saying that's north, is where z is positive. And therefore, if I point north, I'm hoping this is correct. If I point north, great, I see my north. And that's what it's going to show me inside the context of this view, is at app position z of 4 in the world, which is to say 4 meters away. That's the way this stuff usually works, is it thinks in meters. I'm going to show my north text. If I want to show something else, this is what I mean by the rapid reload thing. Still over there-ish. And this is being displayed as extruded text. So you can see there's sort of 3D-ish effect to the text. And that's because these are all being displayed as 3D objects in the northward direction. Now, I can also have south. And this way to mass. You can see the text is defined as text. It's yellow. But in addition to seeing that the z-axis is negative, which is to say pointing towards the southern direction, you also see that I have this Euler angles thing set up. Because I talked about how there are two things about objects. One is position, right, where it is relative to me. But the second is pose. And there are a couple of different ways of expressing pose, but Euler angles are a really easy one, where Euler angles are going to be the rotation around any axis. And you can describe it as like, my rotation around my y-axis would be me rotating like this, right? Rotation around my x-axis would be like if there were a pipe right through my midsection, and therefore rotation like this. Z-axis would be more like this. And what I'm doing here is saying, I want my Euler angles to be equal to -1 times this state variable. And the state variable is getting changed over time using the set interval and animated. So that way I can have something that is that's fixed, which is position, and something that's changing, which is its pose. And that's why it's rotating like that. Now, both of these cases we're using text as 3D objects. I don't actually recommend this. If you get yourself into the business or you're starting to want to do some AR work, don't use 3D text. And the reason you shouldn't use 3D text is because you have to render a lot of polygons and do a lot of math to convey a relatively small amount of information. Right? Each of these letters has like a dozen to 2 dozen polygons if you want to look any good. So instead, I like to use planes that have text rendered onto them. And see, now down here, I have a what's called a sine node, which is purple, x position of +4, which is to say it's the westerly direction. I've got it rotating on its y-axis. That's why it's spinning like that. And if I wanted to say, I don't know, Vermont is that way, right? Reload and be able to see that at some point. Here we go. There's Vermont, and you can see it rotating around. So the idea is to make it easy to put into space things that tell us about the world around us, right? Make it easy for us to do in just a couple dozen lines. And of course, behind me is going to be, there it is, east. So that's the core idea, right? Trying to use this structure, right, to be able to convey text, to be able to convey relative position, and being able to provide certain, relatively simple animations, all with not too much work. So let me move to demo 2. So demo 2, you can see I've got here a sphere, right? And I've got this box. So what's this telling us about the world? Once again, I have a mono view. Once again, I have this idea of a node, which is defining a position in the world. And that's the reason why it's just this little bit of distance in front of me here. It's to say that's 2 meters below me and 2 meters in front of me. I'm going to have my sphere, which is green. And then I have a second node that is co-located with the sphere. And this is actually an important idea. When you deal with 3D space, you should separate the ideas of position from objects. Because you can actually define very sophisticated spatial relationships by saying one node has a relationship with another node, and these are all virtual positions in space, and then only put, say, an object, attach it to like that last node. So what's this doing? I have a sphere, which is located 2 meters in front of me and 2 meters down. It's green. Yeah, but what's with the little Star Wars cube down there? Well, I have a second node that does not have any change in position. It's co-located with my sphere, but it's rotating. And then I have a node that is attached to that node, right, a child, which has a position that says it's 2 meters behind it. So what does that mean? What it means is you can think of it as being on a stick, and that stick is the 2 meters distance between the first node and the second node. But because my middle node is turning, that node, whatever is attached on the outside of that stick, is what's moving around. Right? It's being turned by the center. And then, of course, that node that's 2 meters out, that's the one that has the box. And that's the one that also has a texture that, by the way, is pointing to this little Star Wars image. If we wanted to, we could go point to a different image. What image should we pick up? Cat. Well, it's a goofy looking cat. We can copy this image address. I can bring it back over to here, and I can replace this path with a URL to that cat, and we will see how well that works. Ah, there we go. Right? And so the idea is that you can express not only colors for these objects, but also textures that can be based on images you get from the web, have local, whatever. And then if I wanted to, if I really want to make that cat earn that little concerned look it has, I can actually make the node tumble on all 3 axes separately from the question of its motion. Right? So now I can have things that rotate or that change their orientation independent, right, of their axis of motion relative to whatever that center point is. I know I just used a bunch of geometry words. Is folks with me okay? Okay. Now, one other thing I would just note here is that all of this is kind of not even, it's using where I am, right? It's taking advantage of my position, but it doesn't really actually care about where anything else is. And when I talk about things being augmented reality being about context, this right here would probably be as useful if I turned off the preview and just had a black background instead. And this allows you to sort of make a better distinction between what is it about this that's VR, right, just about 3D stuff in the world, and what is this is about augmented reality, which is taking advantage of the things that are just true about my world. All right, let's move to the third demo. The third demo is about interactivity, because usually this is only going to be really useful if you're not just showing things, but you actually have the ability to modify it as well, or interact with the world as well. And I try to provide easy access to simple interactivity through what I'm calling a button, and then you'll see a touch as well. You'll notice this is all inside a touchable mono view. This stuff is all in a position a little bit further away from me, which I put just so that it would be easier using a little stand here. But if I were to sort of step back a second, you can see here's a box, and there's a button over there. I haven't pressed 0 times. You sure have. But I have the ability to press it because I put this button in space, and it reacts to press by saying, well, actually, I'm going to tick up my button count by 1, and then my title for my button has that text to it. So this button exists in space, and it's responding to my touches because when I touch my screen, basically it's sort of like making a little laser into 3D world to figure out, well, that touch point, what would it hit of the 3D virtual objects? Oh, it would probably hit that. Great, that's going to now trigger that press event, which then you can have other code that decides how you're going to animate it or what have you. Then I have my box, and there's this button here that takes care of a lot of that for you by just rolling that all into an on-press. Looked at more primitively, I have something else called, I can have a node which can respond to presses in and presses out. So I can have more fine-tuned control of what happens when I press in versus release. Where when I press in, it changes the color to green, but when released, it changes the color to red. Little trick is because I've only hooked in and out here, right? I haven't hooked the what happens if I cancel. If I don't lift off while my finger's on it, it stays green. But if I put my finger back on it and lift off, it does go green. Again, I'm just trying to make it easy to have a high degree, to have interactivity that then lets people express their decisions about the world. Okay. So far, everything we've talked about, though, really can be done in VR, right? Because it's about expressing 3D objects in space and being able to interact with those 3D objects. There's nothing that's taking advantage of our context. Let's talk about our context a little bit. Aside, of course, from the compass part, which we talked about. So this is actually a really pretty simple app. You can see it's even fewer lines than ones we had before, where it is just keeping track basically of my tracking. And you see those little yellow dots? Those yellow dots are how ARKit is keeping track of the world around us. And this is turned on by having debug mode on. So basically, the more dots it sees, the better a job it's going to do in making sure that the virtual objects you have in space don't just kind of fly off in every different direction. You probably noticed already there's a little bit of drift in some things we saw. And that's because if it can't find points of reference, it doesn't know what to do. Now, I'll tell you something else. You move this thing really suddenly, and sorry, I don't mean to cause anybody vertigo, but but ARKit gets vertigo too. It works best when it's being moved at a slow to moderate pace around, so that it can be making better distinctions between, say, this frame, the last frame, the frame before it, to keep track of points of reference, so it can understand, yes, I know where I am now, and therefore it's able to keep on tracking your changes in position. Because otherwise, it can use the gyroscope to figure out your changes in pose. It can do that any day of the week. But figuring out where your position is, that's where the camera comes into play, and for that, I need to have enough points of reference, and I need to have a clean enough reference to my previous screens. Also, if I move it really fast, it gets all blurry, right? Like we've all seen happen with cameras, and that means it can't figure anything out at all. You also notice on top here it says tracking state is normal. If it doesn't, if basically it's kind of just staring at a blank wall, and I can't quite get it to break right now, but if it's staring at a blank wall, it'll go into tracking state of limited. It'll give you that warning to say, hey, this isn't working that well. And we also afford the ability to keep track of that through what we call a tracking provider. So that you can say, oh, wait, if the tracking level isn't good enough, maybe you want to be offering a different experience. All right, let's talk about, that's all nice. Let's see if we can find ourselves some planes. App 4 really has a job of tracking planes because we have turned on plane detection. Oh, hey, they found a plane. All right, clear? And usually when you see a lot of your ARKit or augmented reality demos, they're starting with some form of plane detection, where in order for it to work, it's saying, hey, I found a plane here. And so this is set up, it's a little bit complicated. It uses something called a render prop, where for every anchor it has found, which is to say a plane that has detected in the world, is returning an object, and we're basically filtering to just get the planes and then find out for each plane, all right, well, what is its height and width? And then putting what we call a sign on top of it that's green and with the index number of that plane. See, that's why it says plane 0 here. And the reason why it's backwards is the plane's on the other side. And then we can actually tell it, all right, well, that's kind of cute. How about, instead of just putting a sign up for that plane, find another plane here? I'd love to be able to show the sign functionality. If I could find a plane, oh, here we go. You can see it's also got this ball that's going to bounce on it. Because you can now establish objects that are relative to that plane. The reason, by the way, that we're seeing this effect is that the plane in question is actually horizontal, and I'm drawing it vertically. This is sometimes a sticky bit of business. You need to know what kind of plane you're detecting, and often you need to rotate the Euler angle of it in order to make it work properly. Okay, there's the ball. So that's an example of us also discovering a flaw in my demo code, where I'm pretty sure that in that particular case, I could just say, just slash this out. Oh, hey, come back. There we go. Ah, here we go. Excellent. Put ourselves in a position where we might be able to, nope. Yeah, never mind. Okay, so and that's how we can detect planes in space. For my money, detecting planes in space, which is like the classic demo, it's actually the least interesting one because they're not that reliable. The plane that it finds in space, it wants to move around. And that's the reason why often plane detected stuff can be a little bit jittery. For my money, the best thing in ARKit at this point, here, come on. You wake up for me now? Please show. We can go. I'll show the code even while I'm trying to get this thing to run. Is being able to use what's called image detection. And image detection allows you to take things that it can see in the real world and we'd like to be able to show that. Movie recording. No. Come on. Okay. Well, my ability to demo it may be a little bit less, but if someone wants to see it, you can come up to the front. And you have my sincere apologies if that does not appear to be that QuickTime has decided it doesn't want to play nice anymore. But essentially what's happening here is it's giving you the ability to track not with planes, but with images. And you can take an image. You can even take an image with your camera. And if it detects that image in space, it can use that as a point of reference. And I was just doing that with this business card. And it will detect this business card in space, and then based on the position and relative pose of that business card, it can then position additional 3D objects on top of it. So the way it works is you have an anchor, which is based on my default card. I can then say that I want to put a sign directly over it, which will cover up the card, which is actually something you might have seen like some other demos of, hey, I've got this object and now it's obscuring other objects. It's making use of that idea of putting an overlay of virtual information on top of it. And then I can put an additional 3D objects on top of that as well. This is basically how Vuforia works, where it detects a marker in space, which is, say, a reference image. Based on that reference image, it knows how big that image is, right? It knows it's going to be a 5x5 or whatever. And based on knowing its size and having detected it in space, it therefore knows how far away it is, right? Because if you know how big something is and you know how big it looks to you, you can just calculate that. That's just perspective. And therefore, it can mount things on there relative to it, and it has a much better understanding of where things are in space. That means you can have both position and pose understanding of objects in the world around you other than yourself with a high degree of fidelity. Now, the ability to mount something on a wall without needing a marker or a business card or whatever, it's cool and it's easy to get going, but I find it to be really imprecise and actually somewhat harder to work with to make an impressive demo. I actually found that the little trick of using a business card for it is a really good way to go, because it's something that a lot of people just happen to have in hand. You can throw it onto a desk, and then all of a sudden things mount on top of it, right? You don't have to use some sort of special marker. Also, of note, and this is true, by the way, for both Android and iOS, even though I'm only showing iOS right now, the more complicated the image is, the better it works. It's not some simple geometric thing it's looking for. It's looking for an image of sufficient complexity that you can detect it using basically a convolutional neural network, which, for those of you who know a little bit about machine learning, that's actually a bit of a trick. So higher complexity is rewarded. So I have found using something like that to then mount a virtual display on top of that has the interactivity we've talked about is where the greatest power is for us to be able to take advantage of. Okay, those are a little bit of a gloss, I appreciate. Now, there are a few things that are coming down the pike here that are, I think, hopefully going to be relatively useful. One is being able to have more sophisticated relationships with animations as opposed to just having the relatively simple changes in pose and position that I have support for so far. A second is the ability to integrate with Android, which I alluded to before, where basically the scene form is the limiting factor rather than the AR stuff, which works pretty well. One of the really cool things about iOS is they've just introduced support for being able to recognize 3D images. And you've seen the use case for this in like museums, being able to recognize a statue and being able to bring that in as well. And finally, being able to have persistent AR experiences that can exist between reloads. I find all of this to be some pretty cool stuff, and it's all things I've been working on because, like I said, this is my project, which I've been trying to discover more about. And frankly, if I hear back from you all about different areas you think are more interesting, that would be really helpful to me to understand, to know where to place focus. All of these are available on GitHub, including the demo that I was just doing here, where you'd be able to see more of it because QuickTime crapped them out with me at the end. It is, however, running on my phone. I'm glad to show it to you. There's a Slack channel for the react-native-arkit folks, as well as, and I hang out on as well, answering React Reality questions. And if any of you are interested in learning more about it, or you start to run into issues, it's all very, very friendly people. Yeah? Yeah, sure. And not for nothing, but my the pinned tweet on my Twitter account, which will be on the last slide, which is the @raydac, which will be in a couple slides, has all of these slides up on SlideShare, so you can go review them at your convenience. You good with this? and this. And all of these slides, like I say, are pinned tweet right on top of the @react account on Twitter if you want to be looking at them in more detail. My DMs are open for anybody who wants to have a conversation, because I'm just looking to learn and to make this better, and the way that I'm going to make it better is by making it better for people who are actually interested in doing cool things with it. Thank you so much. And now, can I answer any questions from the group? I'm also glad to talk one-on-one. Yes, sir.
Curious if, I know basically the last do you include a virtual object?
Yeah, so here's how that works. Like the way you've seen those tricks, right? Where like, hey, you have a virtual object and it disappeared behind a tree or something. So here's the gag. What you do to make that work is you detect the tree. You draw a virtual object over the tree. But everything we've drawn so far is adding color to the scene, right? Adding red, adding green, adding yellow. But that's not the only direction math works. You can subtract. So the way that if you have something that's like you have an object and sort of disappearing behind a tree, the way that system is working behind the scenes is detecting the tree, and it is painting basically an eraser over the tree. And that's the reason why as your object goes behind that tree, it's going behind the virtual object, which as it intersects with that eraser is making the object look like it's disappearing. And because the eraser doesn't actually draw any ink or any additional pixels on the screen, right, it looks like it's the real object, right, that's occluding the virtual object, when what's actually happening is you have a virtual object that just got painted over the real one that's acting in that eraser mode. Does that make sense? Yeah, sure. Oh, and the bit.ly is case sensitive, so that if you do it on your phone, you lose the FK. Yes, sir.
Can you repeat again, like what are the use cases of using here, this type of framework for the web as opposed to using if there's also like a performance impact using this type of more complex situation?
Right. Well, I mean, of course, Unity has its own weight that comes along with it, right? And Unity is awesome if you're going to make a game, it has a physics engine. There's lots of stuff that comes with it. Although I will say that I've met a number of the engineers at Unity, and they are very performance aware. And if you're not using a piece of functionality, they will, they're pretty smart at bundle time. I would posit that frankly, there's not much of a performance benefit for say not using Unity, because so much of the load you're going to see isn't about the rendering of the virtual images. It's about getting the camera to be keeping track of the world that's around you. Like when you take a look at like what actually drives energy usage, like a Unity app is no slouch when it comes to energy usage, but it actually compares pretty well to the way like a SceneKit app works if you're sort of building a metal-based application. It's the ARKit that really drives that bus, and it will drain your battery, and I'm pretty sure this guy's battery is pretty low now, even after having just been doing this for 45 minutes. No, I think that the advantage is not so much about performance one way or the other. It's going to be about developer experience. Like if you're looking to build in Unity and you have Unity skills and you're building an app and the experience is going to be inside Unity, I mean, Unity's great for that. Where this is going to be more useful is if what you're trying to do is build a simple experience and you want to be using a JavaScript-y framework that looks a lot more like React, right? Because what I did with this was I took the React tree, right, that DOM, and expressed it directly in the context of augmented reality. And of course that can be changed, be interactive, and what have you. But I think someone who comes from that background would get more value from doing it this way. Also, this interacts more gently with a broader app that might not otherwise be in AR, but is living in the world of React Native. In fact, my last demo, the one that didn't show, included both like a non-diegetic button as to affect what's going on in diegetic space. Diegetic just means like that's what's inside the 3D part. And the where am I trying to go with that? Like that integration outside the context of what's in 3D is where I think this can be adding a lot more value, and is what I'm trying to make easier. Yes, sir. Yeah, it actually already has support for that. Let me quickly get out of the show here, assuming that it doesn't just die. Okay, good. Good so far? All right. Okay, I'm just zooming in a little bit. This is the GitHub page for React Reality, which contains documentation on it. And I'm sorry to be, for anyone who doesn't like scrolling, bear with me a moment. I have actually support for something called AR Model, which allows you to have models and scenes, where models are like the OBJs that you might be getting from a Google Poly, is sort of a good repository for free models, whereas scenes are the sort of AR, the Apple flavor of Collida, complex scenes DAE files. I like using models, the ones I get from Google. You'll find that trying to import very complex models is not rewarded on mobile because you're spending so much of your horsepower just trying to figure out where I am. And now, wait, I'm also supposed to render a couple thousand polygons. Keeping it simpler is usually a good idea. But yes, you can definitely load them in as long as they're loaded locally, which is actually a reason. You can actually load them locally directly through the assets of your iOS project. You can load them locally as part of your React Native bundle. But the other thing you can do is you can download them at runtime from place of your choosing, and then tell React Reality and transitively ARKit to reference them from their downloaded location. So unlike, say, that texture I showed, which you can do directly from HTTP, you need to do an additional download step, which is actually one of the reasons why React Reality CLI distributes a package that includes, and I appreciate this is where it gets all tiny in here, but includes what's called RNFS, which is the React Native File System support module that makes it easy to be downloading things off the web and be referencing local paths. And then that way, I can reference the local path to my downloaded model, put that in, have that all run at runtime. And that actually is another key consideration. I wanted everything to be able to run at runtime. Nothing that you've seen here today requires any asset to be downloaded at the time of binary distribution. It all can happen later. Other questions? Everybody hungry? Thank you so much. I really appreciate it.